Picture yourself in a spacecraft. The engines ignite. Tremors rise through your bones. You're pulled upward, away from Earth, through the clouds, past the last traces of breathable air. The sky fades from brilliant blue to an eerie indigo, and finally, to black. You float. You look down, and there it is, Earth, fragile, round, glowing. You've reached space, right? Maybe. Because here's the strange part. No one can quite agree on where space actually begins. You'd think we'd know. We've sent rockets, satellites, astronauts, telescopes. We've mapped the solar system, walked on the moon, and stared into galaxies billions of light years away. And yet, the boundary between Earth and space is still a blur. Today, we explore that boundary, the invisible threshold called the Kármán Line, and the far deeper question it raises: where does Earth end and the cosmos begin? One of the most persistent myths about Earth is that it has a hard boundary with space, that there's a specific altitude, a sharp line, where air ends and space begins. But the truth is, Earth has no edge. Its atmosphere doesn't stop, it fades. It thins out gradually, molecule by molecule, until it merges with the vacuum of space. There's no wall, no shell, no checkpoint in the sky. Instead, the air becomes less dense the higher you go. By the time you're 50 kilometers above sea level, you've left behind 99.9% of the atmosphere. At 100 kilometers, it's nearly a vacuum, but not quite. Even at 400 kilometers, where the International Space Station orbits, there's still a trace of air, enough to create friction and slowly drag the station down. So how do we define a boundary in a place that has no definitive break? We make one. In the 1950s, Hungarian-American physicist and aerospace pioneer Theodore von Kármán confronted a practical question. He wasn't asking where space looks like it begins. He wanted to know where flight as we know it becomes impossible. At lower altitudes, aircraft rely on wings to generate lift. But as air gets thinner, there's less and less lift to keep you aloft. At a certain point, you'd have to travel at orbital velocity, about 28,000 kilometers per hour, just to stay airborne. That point, von Kármán calculated, was around 100 kilometers above Earth. He proposed that this be the cutoff. Below it, you're in the atmosphere. Above it, you're in space. And so, the Kármán Line was born, an invisible marker 100 kilometers above sea level that supposedly separates Earth from everything beyond. But as elegant as that line sounds, it was always an estimate, based on assumptions that have since evolved. Earth's gravity isn't perfectly uniform. Atmospheric conditions change, and orbital velocity varies with altitude and latitude. The line wasn't physical. It was mathematical and political. The number stuck. 100 kilometers. A clean, round, convenient number. The Fédération Aéronautique Internationale, the international body that certifies records in aviation and spaceflight, adopted it as the official boundary of space. Cross that altitude, and you're a spacefarer. Stay below it, and you're not. No matter how fast you go, no matter how black the sky looks. It became the line that separates astronauts from pilots, rockets from planes, and space missions from aeronautical experiments. But here's the catch: not everyone agrees. In the United States, for example, the Air Force and NASA have historically awarded astronaut wings to pilots who flew above 80 kilometers or 50 miles. That includes many X-15 test pilots in the 1960s, whose aircraft skimmed the upper atmosphere but never crossed the 100-kilometer mark. So depending on your definition, some people are astronauts and aren't, which raises an uncomfortable question. Is the Kármán Line a boundary or a branding decision? To understand where space begins, we need to understand what we're leaving behind. Earth's atmosphere is divided into layers, not walls, but zones of behavior. The troposphere, where we live and weather happens, extends up to about 12 kilometers. The stratosphere comes next, up to around 50 kilometers, home to the ozone layer. Then the mesosphere, where meteors burn up to about 85 kilometers. Beyond that is the thermosphere, where auroras shimmer and temperatures soar to thousands of degrees. And eventually, the exosphere, a ghostly realm where molecules drift for hundreds of kilometers before escaping into interplanetary space. It's in the transition between the mesosphere and thermosphere, somewhere between 80 and 120 kilometers, that the Kármán Line resides. But there's no moment of transformation, no ping that tells you you've crossed into space. Only the gradual thinning of air, the slow vanishing of sky. Even at 120 kilometers, atmospheric particles are present, just incredibly sparse. And so the line becomes more of a narrative convenience, a symbolic passing from one realm to another, not a physical gate. Definitions matter, especially in law, geopolitics, and military strategy. If you're flying at 30 kilometers over a country, you're in their airspace and subject to their control. But if you're orbiting at 300 kilometers, you're in international space, no longer under any nation's sovereignty. That makes the boundary between airspace and outer space extremely important. Under the Outer Space Treaty of 1967, no nation can claim sovereignty over space. But without a fixed boundary, disputes could arise. Could a spy satellite at 90 kilometers be considered an invasion of airspace? Could a suborbital missile test be called a spaceflight? These aren't theoretical questions, they're strategic ones. And so, while science debates where space begins, nations quietly draw their own lines. Most use 100 kilometers. Others prefer 80. Some refuse to define it at all. In the vacuum above us, definitions are made not by physics, but by policy. So, where does space begin? Ask 10 scientists, and you might get 10 answers, each one technically defensible. But perhaps the real answer is, space doesn't begin at a line. It begins at a threshold. It begins when the air stops lifting you, when you can no longer glide or steer, when the horizon curves and gravity feels like a gentle suggestion instead of a rule, when orbital velocity becomes the only thing holding you up. Space begins when you transition from being an object in air to a body in freefall around the planet. That transition doesn't happen at a fixed altitude. It happens over a zone of experience, a place where human biology, engineering, and perception all begin to behave differently. And for each astronaut who has crossed that threshold, the moment wasn't about a number. It was about feeling the sky fall away. The Kármán Line is an idea, an elegant, imperfect solution to an impossible question. It represents more than just altitude. It marks a change in how we move, how we live, how we see ourselves. It's the moment we stop being creatures of Earth and begin our journey into the cosmos. But don't be fooled by the number. There is no true border, no perfect threshold. There is only the invisible crossing, the line between sky and stars. And we drew that line not because space begins there, but because our imagination does.